what will happen? Yeah, this is the one of the activation functions. Some of the cases, what will happen? You will be encounter a plot like this. So this is called as a ReLU, rectified. Yeah, so you can see here the ReLU function is very popular nowadays. So the ReLU function is going to be differentiable at 0. But what will happen if you differentiable at 0? It will still lies in the 0th value only. It still lies in the 0th value. It will be constant up to 0. So what will happen suddenly if you are differentiated at 0.1? It's slightly going to be follow with corresponding to the output. So this is much more efficient way to understand. If you pass the weight, suppose w1 x1 plus w2 x2 plus w3 x3, if you pass some of the weights adding to your activation function, suppose a1 and a2, some addition, not required a1 a2 representation, but I'm just writing some understanding purpose too. So a1 a2 a3, somehow you have to add some of the advantage to weighted to your each and every node, so that it will be actively working together to represent or to classify any kind of the equation or any kind of the function to get the loss, dl by dx loss. So this loss is going to be enhanced in the backpropagation algorithm. It will be works well to identify the patterns corresponding to the features you are going to learn. So this ReLU activation function is very popular because of it's going to be, it may not be differentiable at 0. It may not be differentiable because it's at the same phase. Once you got 0.1, it will be laid on to the next steps. So some of the cases we have a different optimizers also, something called as a gradient descent. We'll plan to discuss this in the optimization algorithms when we're going to be discussed. So something smoothed curve with respect to this ReLU activation function, some smoothed curve like this, arc way smoothed curve. This is also very useful. Some of the cases we need to disadvantage with the vanishing gradient problem in the optimization algorithms. So at that time, it will be going to be very useful when compared to the ReLU activation function. We can also call this as a leaky value for that matter. So just for understanding perspective, we can smooth this some of the activation ReLU activation functions. So we can discuss this in the optimization much more detail. So let's go and see the what is the architecture with respect to the CNN. So we have given the convolutional layer with some of the filters, so that the kernel size, kernel is, this is the filter is nothing but a kernel only, and the kernel size you are given 3 cross 3, and the striding, padding, activation functions you want to be specified. So most probably all the people going to be specified ReLU. You can also trial out with the sigma, that may not be works well for the good results, and you can also trial with the leaky ReLU. That is also some of the cases will work if you have a problem with the vanishing gradient problem. So input size, these are some of the input size. We already rescaled the data specifying with some of the input shape. And convolutional layers, this is some of the hidden layers you can specify with the activation functions you are going to be get. And you can flat it because you have to be get the only the one array kind of the thing, right? At the time you can discuss with the flatting layer. So yeah, these are some of theoretical stuff. So let's compile this. Let's compile this so that we'll get some idea what which matrices we are using and optimizers, and also the loss. So for the binary cross entropy, we're going to be get in terms of train and validation loss. If you are more come across with the categorical, so that we will get into the multi-class classification task for categorical cross entropy, you can say. Fitting of the line, extend and write. We already did in the classical ML. Same here we are going to be. Once you learn any model, this is all the straightforward, I can say. So implementation of the any model in the deep learning is very straightforward. Once you understood what are the different layers we are going to be showcased and how does to compile. This is a compile, every model we can compile like this, and everything we're going to be run like this. That's it. So if you know the concepts of how to construct the layers wise layer, this is much easy when compared to the classical ML. Yeah, compiling with the some 50 hip hop, we already understood, right? Hip hop is nothing but one propagation of backward and also the forward. So that will compute it with respect to learn some of the weights and also the losses. It will give the accuracy results at the end, and also the validation loss and training loss. you can see the training loss is much more much more lower when compared to the validation loss what we had. And when compared to the accuracy results, it's much more higher when compared to the validation loss. So these things will happen, okay, because we are not training on top of the validation loss anything. I mean, validation data sets, anything. They're just testing out with respect to the validation data only. So at the time you eventually learn anything on top of the training data, it may be learned, but if you test by using the unseen data point, it may not be learned properly. So that is a major drawback for any kind of the model, I can say. So you have to be specifically fit that model according to the train and validation loss. So most probably you have to stick with the loss, not in terms of the accurate results. Accurate results going to be help us to understand to get the good results. But at the time, if suppose you are working with some animal classification task, what will happen? Some of the animals maybe looks like same, maybe looks like same. So yeah, some of the animals maybe looks like same. So what will happen? Accurately, it's going to be predicted. Accurate is going to be predicted as 9.95 results at the time with the same two classes, but the two classes are different as far I know, as far you know, right? So system may not be know about that. Accurately, it's predicting as 0.5 results, but you have to be understood these are the two different classes to get the loss. So loss is basically